Hello and welcome for the video demonstration for the final project. I'm Shenal Anthony. My project is MathQ, answer generation for single arithmetic problems. In this video, I will be covering the problem background, the research gap, the proposed solution, demonstration of the prototype, concluding with evaluation and future enhancements. First, we will look into the problem background of the research. MathQ is based on question and answering research. Now, MathQ has three domains which comprise of question answering, singular domain, and mathematical domain. Solving single arithmetic problem is this research area. Now, when it comes to question answering, many researches have been conducted over years as well as in mathematical domain. Now, in single domain, only few, such as Mahaushadha, have been conducted to obtain the output of uh, solving single arithmetic problems. Now, arithmetic questions are based on school education mathematical subject. In school, students who are at the age of 9, 10, 11 have mathematical problems that comprise of addition, subtraction, division, and multiplication. Now, every student has to go through these mathematical problems when they are studying the maths subject. Now, every student does not have the capability of solving each and every problem which they get, as everyone is not has an equal IQ, and some of the questions might be hard. That's where MathQ comes to aid for those who have trouble, or uh, those who have issues when answering, generating answers for those sort of questions. Question answering is a vast area of study that can be extended to many languages. Now, question answering is the main domain for MathQ, as it has been conducted for much domains such as English, mathematical, biomedical, and so on. The main focus of this project is to develop a system where the simple mathematical operation of that comprised of addition, subtraction, division, and multiplication problems can be solved without uh, having any errors. Next, we will look into the research gap of this project. Now, answer generation for different languages and different domains have been introduced over the past few years. And for single language, it has not been researched due to lack of resources. Now, this is because single language is a complicated domain compared to other domains such as English and maths and so on. According to research that I found, the gap was identified as arithmetic operation containing multiplication and division does not have an system to generate answers for those kind of problems, as the research has been conducted only for the addition and subtraction. The research clearly says that the research can be extended for all the four operations, four mathematical operations. So in this research, the author is mainly focused on developing a system to solve mathematical problems which comprise of multiplication and division. This is the bibliography or the reference for the research gap that was identified earlier. Next, we will look into the proposed solution of this research. For the proposed solution, this is the high-level architecture diagram. In the presentation layer, the web application is presented, and then in the logic layer, when the user has entered the problem or the mathematical question, first the system would pre-process the question, as it might contain unwanted characters such as uh, punctuation, ASCII values that are not identified. Uh, Likewise, so those values characters would be cleaned, and a clean record would be passed to the next stage, as the next stage would be the question classification. In this question classification, the system would classify the question according to the uh, label where the category of which the question would be sort into. There are four categories: addition, division, multiplication, and subtraction. So after classifying the question, the keyword identification process would identify the differences of keywords. In this sense, the numerical values, which have in which will play a huge role in generating the answer, and then the other keywords in the question that might help to calculate the answer. With the question classification and the keyword identification, next step is to calculate the answer. Uh, with the question classification, if the question is fall under the category of one of the four, and with the two numerical values that was identified in the keyword identification, the system would go to the next process of calculating the answer according to the question classification. Next, we will look into the demonstration of the prototype. So for the demonstration, I will be first showing you the UI or the front end of the application. So this is the home page, and then you can go into the generate answer section where you have to add the question in this text area. Now the question is added. After the question is added, I have to select the generate answer button, and then the system would generate you the answer here. The question is given, then the category of the question, it is identified as division, and then the answer which has been generated is 10, as you can see. Since this is a division question, the answer is also correct here. And then if you want to try again and go straight back to the generate answer form, and then we have the help section where newcomers who are here to use the system could get to know about the system and how to use the system step by step here. Next, we will look into the model of the core for this project. Now, this is the question classification model or the code. First, we have the libraries which are being imported here, and then for the question classification model development, I have used Google Colab. So the Google Drive is mounted here, and then we have the training dataset and the testing dataset loaded using pandas, and then using the model train method, it is assigned to the xtrain and xtest and ytrain and ytest for the classification assigning the label. And here you can see the class names. The label are the categories, the four categories: multiplication, division, addition, and subtraction. And then the data frame is declared here, and this is the view for the training dataset. As we can see, the question and the label is given. For each question, the label or the category is already given. This is the pre-processing stage where all the unwanted characters such as punctuation, hashtags, and non-ASCII digits, white spaces are being dealt with, and then using the word tokenization to tokenize word using, and then the pot stemmer to stemming. All the tokenization and the stemming is used with the help of NLTK library. And then this is the vector used from the TF-IDF unigram and bigrams. Here, the pre-process method is called upon for the tokenizer, and then the vectorization is being conducted. Here, the fit transform method is used to train the vector. The transform testing and the training data for the two vectors have been assigned, the xtrain and xtest. And then the classification for this model or the project has been done using logistic regression, and the LBFGS solver was used to train the model, as you can see here. And then using the fit method, the logistic regression model is being trained, and then using the predict method, you can predict the final output, and then the accuracy, the F1 score, the recall score, the precision, and the confusion matrix has been printed here. Overall, the accuracy of the question classification model is 97.98%, as well as the F1 score, the recall score, the precision score, and the confusion matrix. This is the code for plotting the confusion matrix that was printed in the previous section here. And this is the results from the confusion matrix. And then we have the pipeline that was created for the TF-IDF vectorizer and the logistic regression model. The pipeline was created to stop the leaking of the accuracy of the model. If it was not conducted, then the model would lose the accuracy, and the prediction would be low. And then using the dump method, the pickle file is the model is saved using the pickle file as an .sav extension. And this is the question classification model. Next, we will look into the APIs and the front end. In order to create the API or the backend of the project, I have used Flask. So this is the Flask project, and the imports of the project is given here. And then we have the Flask route, where the app of the Flask project is given here, and then this is the secret key for the session. And then we have the routes for the project. This is the home route, and then we have the generate answer. The answer showing page, this is the route, and then the try again, MathQ, and this is the run method for the routes. Now we will look into each and every route of in the project. This is the get answer route where the user would enter the question. So here we can see there's an if statement for the post method, and I will show you the where this form entry is coming from. This method is from the post, and this will check if the request has an HTTP post method, which the form can the text area which was shown earlier in the UI demonstration. So from there, the question is given taken from the text area, and then the request is taken here. This is the question, and then it is assigned to the question variable. Here I have assigned the variable to a session variable, so that is it is easy to accessible in other routes and also in other methods as well. And then for the returning, the redirect URL is for the get answer method. So the get answer method is called upon here. So the get answer method is here. If there is no post request coming from the front end, then the route will render the template of generate answer HTML. And then this is the tokenizer and the preprocess method that was described earlier in the question classification model. And here we have the logic or the question generation for the system. From the above, question is passed from the generate answer page to the answers page. It is captured here as the session variable is assigned to a variable called question, and then here this is for the console printing, and then here we can see the question is used to the question is identified as Sinhala. So the MathQ system is only to answer questions which are based on Sinhala arithmetic questions. So other languages questions such as English, Hindi, Tamil would not be accessible. So only Sinhala questions would be accessed here. If another different language question is entered, then the render template would render the page of tryagain.html, which will be shown later on. Now from here, if the question is an Sinhala, then the lang id.classify would give the zero index as an SI. SI means the Sinhala. So after that, the model which was saved earlier and stored in the question classification demonstration is loaded here, and then the file name, sorry, and then here using the pickle.load method, the file is loaded as the model, and then the variable called category will predict using the model.predict method the questions that was entered from the front end would predict the category of the question, and it will be assigned to the variable called category. Now, after the question classification is completed, the next step is to identify the needed keywords in the question. For that, I have used the tokenizer of called singling. This is a single this is a tokenizer created for Sinhala language, which is easier to use, where the user has created a tokenizer along with the POS tagger to post-tag the part of speech tagging for a sentence. So here, using the split sentence method, the tokenization is achieved, and it is assigned to the array called tokenized sentence, and then it is served to the POS tagging or the part of speech tagging. And then here the keyword chunking is conducted where to identify the tag of the NUM. Here NUM means the number. Now every question has numerical values, which was shown in the UI demonstration. In that question also there were two numerical values. So using this method, the what we call the quest chunking here, and the tag, POS tag, which contains the tag of NUM, which is the number, would be assigned to the keywords number array, and then from that array, the two numbers are extracted and then assigned to num1 and num2. Since the entered question is a string, we have to convert the two string into integer to conduct the calculation for the answer generation. So after converting the two strings into integer, they are assigned to number1, number_1, and number_2. And then according to the classification, if the category is equals to multiplication, then the number1 and number2 multiply, and the answer is assigned to the answer variable here. If the category is division, then there would be a condition to check the highest or the highest number, the highest value amongst the two numerical values in the question. And if the number1 is higher than the number2, then the division is done like this, and then the answer is assigned to the answer variable. If the number2 is higher than the number1, then the answer generation is done like this, and then assigned to the variable answer. If the category is addition, then the two numbers are added together and then again assigned to the variable answer, called answer. And then if the category is subtraction, also in this section we have to check the highest number amongst the two numerical values, just like in the division. According to that, and if the number1 is higher than the number2, then this if statement would be executed. If the number2 is higher than the number1, then the elif section would be executed. Since the question and the category and the answer is being generated and being extracted, the three parameters have been passed into the answer.html page, which I will show in you a little bit. This is the try again route, where if the user entered a non-Sinhala question in the answer generation, then the template of the tryagain.html page would be rendered. And this is the route for the help page. And if we quickly look into the HTML pages. This is the home page, and then if we look into the generate answer HTML, we have the text area here where to take the input from the user in the front end here. And then if we look into the answer.html page, here is the three parameters: the question, category, and the answer parameters, which are being passed from the route to the page or to the HTML page, are taken here and then displayed in the front end. And this is the HTML page for the help page, and this is the CSS. And on the left, you can see the document structure. Here is the dataset folder where the two testing and training datasets are available, and then the two datasets to calculate the accuracy of the system. And then we have the templates folder where all the HTML templates are given here. Then app.py, the main Python file to run in the class project. And we have the two version of the model and the logic.py to calculate the system accuracy of the project. If we quickly look into the logic.py, the dataset is loaded here, and then the length of the dataset is get from the len attribute, and then as in the previous logic, the same logic is run through here, and then in, at the end, the actual answer and the generated answer is checked as if they are equals, then the number of correct answers would increase. If not, it would skip this stage, and the system accuracy is calculated like this. So this is the demonstration for the implementation. Now we will look into the evaluation and future enhancements of the research. Now for the evaluation, I have conducted expert evaluation where technical experts, domain experts, and beginners have been uh, taken into consideration of evaluating the research in under 4 criteria, and then a self-evaluation has been conducted over the research, and then the focus group testing where selected testers have been evaluating the research, the prototype, and the thesis as well. And then finally, the functional and non-functional testing. The functional and non-functional evaluation have been conducted over the requirements that was identified in the project introduction, project requirement specification stage. And for the evaluation, that was it. Next, we will look into the future enhancements of the research. As the research was conducted, the question classification approach was achieved using the logistic regression. Now, if the question identification was to conducted with the help of deep learning approach, the accuracy could have gone uh, higher than what was got from the research. And another enhancement would be voice input and image capturing over text input. The prototype I have created, the user have to input the text. Now, when it comes to Sinhala language, it is hard to type in Sinhala words in a web application. Now, if it were to input voice or scan an image, scan the question over a book or a letter, that might be very useful and user friendly, as it won't have any issues when it comes to entering the question. Another enhancement would be to show how the question is solved, generate steps on how to solve the problem. Uh, this research is mainly focused on students at the age of 9, 10, and 11. So the students, teachers who are using the system would much be appreciate the not only the answer but also the steps on how to solve the problem is given, so they could I, they could see the problem and uh, see how to get the answers for themselves, and then the system would be much helpful in more than now. Uh, another enhancement would be uh, having an unsupervised learning approach. As the author has created the two data sets, the first one for the classification and then the second one to calculate the system accuracy. The label dataset, which was taken into the question classification stage, it was a supervised learning approach. So if it were to develop using an unsupervised learning approach, then the scope of the project would increase, as it would may give the chance to solve questions which are out of scope, such as complicated questions, which comprise of the four mathematical operation, and then it would help. It would be a much help for the students uh, to enter different questions for into the system and then generating the answer. So that has been the research, the future enhancements of the research, and this has been the video demonstration for the project, and thank you.